Imagine you're in math class and you're presented with a quadratic equation. You may have an idea as to what these look like and you may have seen the quadratic formula, but maybe you don't quite understand what's going on beneath the surface. Why does the quadratic formula solve quadratic equations? The first step to solving any problem in mathematics, no matter how easy or difficult, is to understand clearly what the question is asking. So our question for today goes like this. Given a general quadratic expression, find values for x which sets the expression to 0. To make sure we understand what's being asked, let's look at the key words used here. A quadratic expression is something that looks like this. It's an expression where the leading term is a power of 2. But we also have this general keyword thrown in here. A general quadratic equation means that we don't know how many of each term we have, so instead we'll call them A, B and C. It's also noteworthy to state that you cannot allow A to be equal to 0. If you allow A to be equal to 0, then it gets rid of the quadratic term and just leaves us with a linear equation. Lastly, we're asking where this general expression equals 0. So how do we go about finding a solution to this problem? So far we've been looking at quadratics that look like this. Ax squared plus bx plus c is equal to 0. We just said that a has to be non-zero, otherwise we would not have a quadratic equation, so we're going to divide everything out by a, which will give us the new equation. X squared plus b over ax plus c over a is equal to 0. B over a is just some number, so we're going to relabel it as capital B, and we'll make a note that b is equal to little b over a, just to keep things tidy. C over a is also just some number, so we'll do the same thing for that. The first method that you can use for simple equations is a method known as factoring. To give us an idea as to what this is and how it works, I need to tell you that a quadratic equation has at most 2 solutions. Or if you allow the square roots of negative numbers, it has exactly 2 solutions, but that's beyond the scope of this video. This is thanks to a theorem known as the Fundamental Theorem of Algebra. This is the only piece of information that I will not be explaining in this video, since we're focusing specifically on quadratics, but you can look up sources about this theorem. There was a Numberphile video on it a while back, and I'll leave a link to that if you want to check it out. Let's suppose that we do have 2 solutions, and we'll call the numbers that satisfy this condition x1 and x2. Now let's look at the equation. Y is equal to x minus x1 times by x minus x2. We'll notice that if we let x equal to x1 or x2, then y will be equal to 0. So this equation has the same roots as our original equation. Now let's expand out the brackets. We get that y is equal to x squared minus the sum of the roots times by x, plus the product of the roots. Since this is just another representation of our starting equation, the coefficients of each term should be equal. Therefore, capital B is equal to the negative sum of the roots, and capital C is equal to the product of the roots. So if you can quickly identify 2 numbers that multiply together to make capital C, and add together to make negative capital B, then factoring is the way to go. But if there's no obvious answer, you're going to want to consult the quadratic formula, which can be used to solve any quadratic equation. I'm now going to show you where that comes from. With our new equation, we're going to exploit a link between algebra and geometry. I'm going to draw a square and I'm going to say that it has a side length of x. This means that the entire square has an area of x squared. Now I'm going to glue a rectangle to the side of this, which has a side length of b on 2. I'll do the same with the bottom of the square. Let's look at the area of this new shape. We have a square that has an area of x squared, and we add the area of the 2 rectangles. Each of them has an area of x times b on 2. So in total, our shape has an area of x squared plus bx. Our shape looks like a square that has a corner cut out of it. The area of this big square would be x plus b on 2 all squared. To get the area of our shape, we're going to have to cut out the corner, which has an area of b on 2 all squared. We now have 2 different formulas for the area of our shape. Those amongst you who are observant may have noticed that if we just add c to our first area formula, we get x squared plus bx plus c, which we said by definition was equal to 0. So if we add c to our other area formula, we should also get 0. X plus b on 2 all squared minus b on 2 squared plus c is equal to 0. When we get a quadratic that looks like this, where we've combined our first and second term, we say that we've completed the square. Maybe you've heard that term before, but that's where it gets its name from. The good thing here is that we can nicely rearrange this equation in terms of x if we add b on 2 all squared to both sides and then subtract c. Then we take both the positive and negative square root of both sides and simply take away the b on 2. The last thing that we need to do is we need to remember what capital B and C actually stand for, and we need to replace them with our original values, which leaves us with the quadratic formula. A quick note regarding the quadratic formula is that we actually get information about our solutions just from this small section here, b squared minus 4ac. This section's known as the discriminant. If we're going to take the square root of this, and it's a positive number, then that should correspond with giving us two unique solutions. If it's 0, then the positive root of 0 is the same as the negative root of 0, so we'll get a repeated solution. If it's less than 0, we're not going to have any real solution to this. Again, if you allow the square roots of negative numbers, you can happily find solutions, but that's not for this video. Hey everyone, I just wanted to pop in and say a huge thank you if you got this far into the video. There will hopefully be a part 2 of this out soon, where I talk about the geometry of quadratics and some of the theory and intuition that goes into that. So if you like what you've seen here and you want more, then please hit like and subscribe, and if you didn't like it, then please let me know in a comment, telling me what you'd like to see instead. Thank you for watching.